For this video, we're going to talk about how to solve a Bernoulli differential equation. Bernoulli DEs can pop up if you're dealing with a fairly complicated drag force problem. We like to solve them because we can actually find a solution to this differential equation even though it's a nonlinear differential equation. And I like to do it because it's an example of how to solve a differential equation using a substitution. So right here is a general form for a Bernoulli differential equation with x as the independent variable and y as the dependent variable. Let's make up a really simple example and we'll try to solve it. Okay, here's an example. My p of x is 2, our q of x is 3, and our n value I just made up is 4. For the first step in solving these Bernoulli DEs, we're actually going to divide by the y to the n. Whatever this y to the n is, we're going to divide through by that. And if we do that, we're going to get y to the negative fourth, y prime, plus 2y to the negative third equals 3. We got y to the negative third because we divided y by y to the fourth, and the power comes out to be negative 3. Now is the part where we use a substitution. I'm going to use the letter v for our substitution in case we have to do a u substitution later. And v is always going to be y to whatever power turns out to be right there. So in this case, it's y to the negative third. Anytime we do a substitution like this, we're also going to need to take a derivative of our substitution variable with respect to the independent variable. So dv dx in this case. So y is actually a function of x, so we're going to do a power rule and we're going to do a chain rule, and this is actually an implicit derivative. So this is negative 3 y to the negative fourth power, and since y is a function of x, we're going to have a y prime in there as well. Now here's what's cool about the substitution. We obviously have y to the negative third power is v, and that's going to go in right here. But now we also have this y to the negative fourth y prime, which appears right here. So it might make sense to isolate this just by dividing by negative 3. We have negative 1/3 dv dx equals y to the negative fourth y prime. And now we can easily make the substitution. Y to the negative fourth y prime is just going to turn into negative 1/3 dv dx plus the 2 is going to follow. Y to the negative third power is now v equals 3. Now if we multiply through by this negative 1/3 term, we get, I'm just going to call it v prime now, minus 6v equals negative 9. So what our substitution has done is it's actually turned our Bernoulli differential equation into a first order linear differential equation. And this always happens. We're always going to divide through by y to the n. Our substitution is always going to be y to whatever power turns out right here. And we're always going to end up with a first order linear differential equation. Fortunately, at this point, we know how to solve first order linear differential equations. We use the integrating factor. That's going to give us an integrating factor of e to the negative 6x. We're going to multiply this integrating factor through the entire differential equation. The left-hand side of the equation becomes a product rule. We integrate both sides. And we simplify and solve for our dependent variable, which now, after our substitution, is v. Okay, if this problem started off as a first-order linear differential equation, we would be finished at this point. However, it started off as a Bernoulli equation, and the dependent variable we're trying to solve for is y. We found v. We need to substitute back in for what v is. V is y to the negative third power. Now all we have to do to solve for y is raise both sides of the equation to the negative 1/3 power. And that's it. If we were given an initial condition, we would plug it in right here. But since we weren't, we're just going to call that the general solution to the differential equation, and we'll be done with it. Alright, let's try another one in the video quiz. Solve this Bernoulli differential equation. Make sure that you put the thing in the right form first before you start making too many substitutions. This one is pretty fun because you get to solve a slightly more complicated first-order linear differential equation in the process. So good luck, and I'll see you in class.